close your eyes for a second and picture a construction site. What do you hear? Maybe that classic hammer sound, thump thump. Or, the smell of fresh sawdust.
Yeah, the buzz of saws, maybe shouting over the noise.
Exactly. It's an image I think most of us have. It feels, well, traditional, almost ancient in some ways.
Definitely steeped in history.
But what if that familiar scene?
Oh.
What if it's starting to fade, or at least morph into something fundamentally different? What if tomorrow's job site sounds and even thinks in a whole new way?
A big shift.
Welcome to the Deep Dive. Today we're diving headfirst into tomorrow's toolbox. We're looking at how technology isn't just tweaking construction, well, it feels like it's fundamentally reshaping it.
Right, from the ground up.
Think digital blueprints that know every single bolt, schedules that practically predict the future, buildings designed for the planet. Makes you wonder, doesn't it? Are we staring at a kind of second construction revolution?
That's the big question we're exploring today.
And our mission, for you listening, is simple. We've got this stack of sources you provided, articles, research, notes, and we're going to pull out the absolute core insight.
Giving you the essential download, basically.
Think of it as your shortcut to getting really up to speed on how we're building things now and how we will be building them. Expect some surprising facts and hopefully a few aha moments.
Hopefully more than a few.
Okay, so let's start right at the beginning. The foundation, you could say. For ages, construction relied on flat, 2D drawings, right? Paper plans, maybe CAD files later on.
Right. Lines on a page or a screen. Very detailed, but fundamentally flat.
But our sources keep talking about this radical shift to something called 3D parametric modeling. What does that actually mean for a project, not just in theory, but on the ground?
Okay, yeah, this is key. Parametric is the important word there. It means the model isn't just shapes, it understands rules and relationships.
Rules? How so?
Well, think about it. In old 2D CAD, a wall is just lines. But in a parametric model, that wall knows things.
Knows things. Like what?
It knows it's, say, an 8-inch thick concrete wall. It knows its material properties. It knows it connects to this floor slab below and that beam above. It understands its function.
Ah, so it's got intelligence built in.
Exactly. And because it understands those relationships, if you change something like the floor height, the model automatically adjusts everything connected. The wall height changes. Maybe a window within it adjusts too.
Wow. Okay, so it's not static.
Not at all. It's dynamic, rule-based. This makes designing and editing so much smoother, and it catches potential coordination errors, things that would clash way earlier. You're essentially building it virtually, piece by piece, understanding how it all fits together before you break ground.
And this intelligent 3D model, that's the heart of BIM, right? Building information modeling.
Precisely. BIM is the framework that holds all this intelligent parametric information.
Our sources describe BIM as a vessel in which to load every bit of electronic data. It sounds huge, like a digital twin of the whole building.
That's a perfect way to describe it. A digital twin. And the amount of data you can load in is just staggering.
Okay, so what kind of data are we talking about beyond just the dimensions and materials?
Oh, everything. Think specification data, the weight of a beam, the fire rating of a door, the color of the paint, even maintenance schedules for equipment.
Maintenance schedules, really?
Absolutely. Installation instructions, product warranties, how often something needs servicing, even productivity rates for installation, and, crucially, cost information.
So cost is embedded right in the model element.
Directly linked. So BIM becomes this virtual representation of a physical facility, like the standards say. It's a shared knowledge hub. Everyone, architects, engineers, contractors, even the facilities manager later on works from the same intelligent model.
That must cut down on mistakes hugely.
Dramatically. Less waste, fewer errors, better quality overall. Because everyone's seeing the same integrated picture.
Let's make that concrete. Pun intended, I guess. Our source, Building Construction Illustrated, mentions things like, say, the minimum thickness for a concrete foundation wall being 8 inches, or specific types of masonry bricks and mortar. Where does that info live in BIM?
Right. In the old days, that spec might be buried in a separate document, maybe page 347, section B.
Or pinned to a wall in the site trailer, maybe.
Exactly. With BIM, that 8-inch thickness rule, the specific mortar type, its fire rating, its applier, its cut, it's all linked directly to that digital wall in the model.
So you click on the wall and boom, there's the info.
Instantly accessible. For the architect, the estimator, the site foreman,
Right.
anyone. It's a single source of truth. No more hunting, no more guessing, no more using outdated specs. It just massively reduces misinterpretations.
Okay, that leads perfectly into one of the biggest buzzwords around BIM: clash detection. The promise of finding problems before they happen on site sounds almost too good to be true. How effective is it really?
It's incredibly effective. It's one of the most immediate, tangible benefits. Clash detection, as the CMAA standards define it, is basically software checking for interferences. It looks for where things improperly intersect.
Like pipes running through beams.
That's the classic example. You digitally combine the architectural model, the structural model, the MEP model, mechanical, electrical, plumbing, and the software flags. Every single place where, say, a duct hits a beam or a pipe clashes with wiring conduit.
And this happens during design.
Yes, exactly. As Halpin points out in his book, it brings all of these interference problems to the fore during the design stage and not during the hectic construction process.
Which saves, well, a fortune, presumably.
A fortune is an understatement sometimes. Think about finding that duct beam clash after the beam is installed and the ductwork crew is on site, ready to go.
Nightmare scenario. Delays, redesigns, cutting, patching.
Exactly. Stop work orders, finger pointing, huge cost overruns. Clash detection finds that problem on a computer screen months earlier when it's just a few clicks to fix. It literally eliminates a massive category of common, expensive field problems.
So it's proactive problem solving on a huge scale.
And it goes beyond just clashes. Because it's a virtual representation, you can run all sorts of analyses: structural load testing, energy consumption simulations, daylighting studies, even acoustic performance.
All before you build anything.
All before you build anything. You can optimize the design for performance based on these virtual tests. It's about making informed decisions early, based on data, not finding out the hard way during construction, or worse, after occupancy.
Okay, so BIM transforms design and catches problems early. That's huge. Let's shift gears slightly to time and money. Scheduling and cost control, the classic construction management challenges. We know traditional methods like Gantt charts and the critical path method, CPM. How do these new digital tools change the game there?
This is where it gets really dynamic.
Yeah.
We move into what's called 4D BIM, the fourth dimension being time.
4D, so linking the 3D model to the schedule.
Precisely. It dynamically links the project schedule activities, those critical path tasks, directly to the 3D objects in the BIM model.
Okay, what does that look like?
Imagine watching an animation of your building assembling itself over time according to the schedule. Walls go up, floors get poured, the facade gets installed, all visually sequenced. It's a graphically rich and animated representation, as the CMAA source puts it.
Wow. So you can literally see the construction plan unfold.
Yes. It's incredibly powerful for communicating the plan, coordinating phasing, seeing how different trades will interact in specific spaces at specific times. And critically, it supports what-if scenarios.
What if this delivery is late? What if we sequence this differently?
Exactly. You can simulate the impact of those changes on the timeline visually. You can rewind, fast forward, test different approaches. It makes the schedule a living visual tool, not just a static chart.
Thinking back to Halpin's example, that 10-story office building with underground parking, visualizing that sequence, excavation, concrete, scaffolding, facade, it's complex.
Extremely. With 4D, you could visually track the concrete crews floor by floor. You could simulate different strategies for leapfrogging, the temporary shoring supports to speed things up. You could optimize the slab pours to avoid bottlenecks.
It provides insights you just wouldn't get from a bar chart.
Far beyond it. For you, listening, it means you can essentially walk through the build months ahead, spotting potential log jams, resource conflicts. It makes the whole process much more predictable, like having a crystal ball for your project plan.
Okay, time is predictable. Now the money. How does this tie into cost management? Accurate estimating is always the goal.
That brings us to 5D BIM, the fifth dimension cost.
Adding cost data to the 4D model.
Essentially, yes. Remember how every element in the 3D model knows its properties? In 5D, it also knows its associated costs. The concrete, the rebar, the formwork, the labor to install it, all linked.
So the model understands the cost implications of the design.
Inherently. This allows for what the CMAA calls a parametric and dynamic quantity takeoff. The model automatically calculates the quantities of materials needed, no more manual counting from drawings, which is super tedious and error-prone.
So faster and more accurate estimates.
Much faster, much more accurate. And this frees up the estimators. Instead of spending hours just counting widgets, they can spend more time on actual cost analysis.
Like value engineering, comparing options.
Exactly. Analyzing different design scenarios, identifying real cost-saving opportunities. It tackles those big challenges around tracking job costs and variances the construction management jumpstart mentions. If the design changes, The cost impact is visible almost instantly, not weeks later.
So cost becomes integrated, not separate.
Totally integrated. It aligns with that PMBOK guide idea that planning artifacts need to stay integrated. Cost lives within the model, evolving dynamically with the design and schedule.
We've got these incredibly smart digital models handling design, schedule, cost, but construction is still about people and processes on the ground. How do things like lean principles fit in, these more human-centric approaches?
That's a crucial connection. Technology is a powerful enabler, but process and people are where the rubber meets the road. Lean construction is all about maximizing value and minimizing waste.
Waste in what sense? Material waste?
Material waste, yes, but also wasted time, wasted effort, rework due to errors, waiting for materials or information, inefficient movement. Construction's unfortunately full of it. Lean aims to systematically eliminate that waste.
How? What are the tools?
A key one is the Last Planner System, or LPS. It tackles the chronic problem of unreliable workflow.
Ah,
The fact that often only about half the tasks planned for a week actually get done.
only half. Wow.
Yeah, it's a known issue. LPS combats this with collaborative planning. Instead of just top-down schedules, it involves the last planners, the foremen, the crew leaders, the people actually doing the work in detailed weekly planning.
Making sure the plan is actually doable.
Exactly. Making sure tasks are well-defined, everything needed is ready materials, info, equipment. The preceding work is done. It uses look-ahead planning to identify and remove constraints weeks in advance.
Clearing the roadblocks before they stop work.
Precisely. And techniques like pull planning, where you plan backward from milestones, ensuring activities only start when the next trade is ready to pull the work from them. It creates a much smoother flow.
It sounds very adaptive, very responsive.
It is. It aligns perfectly with the PMBO guide's emphasis on adapting to change and tailoring your approach. Lean is inherently agile.
Yeah.
It's about designing a workflow that's flexible and optimized for value delivery.
So you have the digital intelligence from BIM and the process intelligence from Lean working together.
That's the ideal synergy. And you can speculate about where that goes next.
Like, could technology enhance Lean even further? Imagine sensors on site feeding real-time data back into the planning process.
Absolutely. Let's really push that idea. Imagine sensors tracking equipment, location, and usage, material deliveries, even worker movements, anonymously, of course, just tracking workflow.
So the last planners in their weekly meeting get live updates.
Exactly. The system flags that a steel delivery is delayed before the crew shows up expecting it. Or it shows the excavation is ahead of schedule, freeing up resources. Real-time data for real-time adjustments to the look-ahead plan or the pull schedule.
Managing those buffers, time, materials, space dynamically.
Dynamically. Maybe even using AI to suggest optimized sequences or flag potential errors based on patterns. It moves beyond just reacting to problems, towards actively predicting and engineering them out. It's truly adaptive management, like that concept from ecology mentioned in sustainable construction. Recognizing things are always changing and building a system that learns and adapts.
That paints a really different picture of a future job site.
Okay, let's shift focus from the process to the product, the buildings themselves. Our sustainable construction source talks about buildings that are incredibly smart and green. This feels like a huge departure from just building boxes, doesn't it?
Oh, absolutely. It's a fundamental shift. The sustainable construction movement isn't just niche anymore. It's becoming the standard, especially for commercial and institutional buildings.
What's the core goal? Just energy efficiency.
It's much broader. Maximize occupant health and productivity, use fewer resources, reduce waste over the whole life cycle, lower operating costs. It's holistic. And certification systems like LEED, Green Globe, BREEAM are driving this. Think about Harvard having, 93 LEED buildings? That's mainstream.
Can you give us some real-world examples of what this looks like?
Definitely. Look at the National Renewable Energy Labs Research Support Facility, the NRAL-RSF. Its windows are incredibly smart. Some are electrochromic, meaning they tint electronically to control glare and heat gain.
Tint on demand. Yep. And other windows are operable, tied into the building automation system. The system actually emails occupants when it's a good time to open their windows for natural ventilation based on outside conditions.
The building emails you. That's wild.
It shows that level of integration. Or take the Shanghai Tower. Its twisting shape isn't just for looks. It cuts wind loads by 24%, which saved 25% on structural steel. That's massive efficiency.
Wow. Design driving resource savings.
And it uses geothermal energy, hundreds of wind turbines on top, rainwater harvesting. It's an integrated system designed for high performance and low impact. Monumental examples, really.
So these buildings aren't just passively green, they're actively managing themselves and interacting with occupants.
Very much so. They're responsive.
How do they achieve this without just packing in tons of energy-hungry equipment? You mentioned passive design.
Right. Passive design is key. Using the building's form and materials intelligently, things like orientation for sun, using thermal mass, thick walls that absorb and release heat slowly, natural ventilation strategies.
Like the NREL example, opening windows instead of running the AC.
Exactly. And the system is smart enough to shut down the local heating or cooling if a window is open nearby. Simple logic, big energy savings. Other techniques include night ventilation, flushing the building with cool night air, or earth tubes that use the ground's stable temperature to precondition incoming air. Very efficient.
And it's not just energy, right? There's a big focus on the indoor environment itself.
Huge focus on indoor environmental quality, or IEQ. Shocking, but indoor air can be way more polluted than outdoor air.
Really? Why?
Off-gassing from materials, paint, sealants, carpets, furniture, core ventilation. So IEQ looks at air quality, yes, but also lighting quality, access to daylight and views, acoustics, thermal comfort, the whole experience.
So material choice becomes critical.
Absolutely critical. Choosing low VOC materials, that's volatile organic compounds, designing the building envelope properly to control moisture and prevent mold. It's all about creating a healthy indoor ecosystem.
Healthy and productive spaces.
That's the goal. Using efficient lighting like T8s and T5s, harvesting rainwater, using green roofs or planters to manage stormwater, it's all interconnected. It's building spaces that actively support well-being and are resilient.
Okay, these buildings sound amazing, but they also sound complex. What happens when they reach the end of their useful life? Are we just creating high-tech rubble?
That's a really important question, and it leads to concepts like design for deconstruction or DFD.
Designing it to be taken apart easily.
Essentially, yes.
Yeah.
Thinking about the end of life right from the beginning. Choosing materials that can be easily separated, recovered, and reused or recycled.
Like metals and plastics.
Right, materials that retain their properties after recycling. Using connections that are mechanical, like bolts, instead of permanent adhesives where possible. The idea is to close the loop, minimize landfill waste, but also minimize the embodied carbon, all the energy that went into making those materials in the first place.
Turning demolition into resource recovery.
Exactly. Making it more like disassembly. There's an economic angle, too. Salvaged materials can offset costs, or even be sold. It shifts the thinking towards a circular economy for buildings.
Okay, putting this all together, the BIM, the 45D, the lean processes, the sustainable and deconstructible buildings, it really does feel transformative. Is this that second construction revolution we talked about at the start?
You know, looking at the sources, particularly the shifts described in the PMBOK guide, the signs point strongly towards yes. It talks about disruption from technology and new approaches.
In what way?
There's this shift mentioned from a single project delivery model to an ongoing delivery model. Thinking about buildings more like products with a long life cycle, meaning support, sustainment, evolution, often with the same core team involved over time.
Ah, so not just build it and leave it anymore.
Right. It's a move away from seeing every project as a completely unique, one-off thing, like Halpin described the traditional view. Now it's about managing the asset over its entire lifespan. That feels like a pretty fundamental, revolutionary change in philosophy.
If the industry is changing that fundamentally, the people in it must need to change too. How does the construction professional of tomorrow need to think differently? What skills, what mindsets are crucial?
Adaptability is huge. And collaboration. Sustainable construction emphasizes this need for intense collaboration owners, designers, builders, operators, even bankers and real estate folks, all working together seamlessly.
An integrated design process.
Exactly.
Yeah.
Fostering a seamless project team, not siloed off by contracts or self-interest, but genuinely sharing responsibility for the owner's goals. That's a world away from the sometimes adversarial relationships you read about in older texts.
Breaking down those traditional walls between disciplines.
Completely, and that requires a different mindset. Peter Drucker's insights are relevant here. He said innovation has to be built into organizations. You can't just react. You have to systematically abandon yesterday to create tomorrow.
So continuous learning is non-negotiable.
Absolutely. Professionals need to be adaptable, constantly growing their skills. For you listening, it means embracing new software, understanding new materials, learning to work effectively across different teams. Lifelong learning isn't just a buzzword, it's a requirement.
It also sounds like the focus shifts. Maybe less about just being efficient doing things fast and more about being effective doing the right thing.
Precisely. Drucker made that distinction too. Effectiveness isn't just efficiency, it's control by performance and results, getting the desired outcome.
And the PMBOK guide reflects that.
It does, shifting focus from just deliverables to project outcomes. What value did we actually create? Tomorrow's pro needs to constantly tailor their approach, adapt to the context, understand the stakeholders, really grasp the voice of the customer.
Delivering real value, not just ticking boxes.
Exactly. And that requires strong leadership skills, even if you're not formally the leader. Promoting transparency, integrity, empathy, as the PMBOK guide says. Creating an ethical, adaptable environment where people feel safe to question things.
Critical thinking becomes key.
Absolutely. Questioning assumptions. Considering different views, like that Japanese decision-making Drucker described, focus on really defining the question, getting consensus, not just rushing to an answer. It's about collective intelligence, deep understanding.
So we've really covered a lot of ground. From BIM laying the digital foundation, extending into 4D time and 5D cost.
Through lean, streamlining the process on site, making workflow more reliable.
And into sustainable design, creating buildings that are smarter, healthier, and designed for the long haul, even for deconstruction.
It's a huge convergence of technology and process innovation.
And we've seen how these aren't just tools, they demand a whole new way of thinking. Collaborative, adaptable, integrated, value-focused.
Definitely a paradigm shift.
So as we wrap up, here's a final thought to leave you with. As technology keeps accelerating, as AI gets more involved, as robotics potentially enter the field, what are the truly human qualities that become most valuable for construction professionals navigating this revolution, beyond the tech skills?
That's a deep question.
How do we make sure that in this push for efficiency and innovation, we stay grounded? That we remember the ultimate goal is creating spaces that genuinely serve people, enhance lives, and coexist responsibly with our planet. What keeps the human element central in tomorrow's toolbox?